So for homework last night, you had to do these first two, and then I just had you complete the second two. So I did blow them up for my answer sheet here. One thing that I noticed on people who did theirs wrong. So maybe there were people who did theirs right and didn't do this either, but almost everybody who did theirs wrong all made the same common mistake. And that mistake was not labeling along the line you're supposed to profile. So every single person who had this wrong, their labels were either wrong or non-existent. So I know you can do this without doing it, without labeling them, but you leave yourself open for making mistakes. And every single person who had this wrong either had a mistake with their labels or didn't do it. Take my word for it. This is not my first day. Labeling is really important, and labeling along the line like this is important. And the reason you do that is because when you come in to do your marks on your scrap paper, you still want to be able to see those labels. You don't want to be trying to hold this still, but peeking underneath it to see what line it really is. So definitely keep those labels there, and so you can see them. So once everybody did that, it was looking pretty good. And I think I checked everybody's yesterday. Your graph should have looked like this for A to B. And then your other homework assignment was this one, which was E to F. So this is going down one. This is the E to F one. I think I checked in on everybody's. The biggest mistake I found here was E. So what you should realize is that area in between these 100s, that's higher than 100 there. So that's why mine does curve up there. But then a lot of people wanted to call E 110. And I get where you're coming from. You were going 50, 60, 70, 80, 90, 100, 100 again. And you thought it kept going up. But you have to think about when we made these circles back when in the beginning of the packet. Once you have the circles, everything on the inside is bigger and everything outside those circles is smaller. The other mistake is a bunch of people wanted to call that 50 because 50s were on the outside. But that means if this was 50, where did 90, 80, 70, 60 go? So really what's happening here is this 90 line is connecting somewhere off the map and repeating itself over here. So you do always have to make sure you have all the numbers in order. And in the end, your graph should have looked like that for E to F. Now, for the two I just had you do just now, again, I think it's really important that you do this labeling. And this labeling, again, you want to label it so that when you cover up some stuff with your scrap paper, you can still nicely see your labels. But then the big issues came at the lines that repeated themselves. For example, here and here, those are two 200s. So this area in orange here, will those numbers be higher or lower than 200? Higher. Almost everybody got that one right. Same with over here. This whole section in orange here, in between 180 and 180, are those higher or lower than 180? Higher. Here's the issue here. This area that I'm highlighting in green, we have a 160 here going this way and a 160 here going this way. So any spot in this green, what number is that going to be? Lower than 160. How do you really know it's lower than 160? I highlighted this whole area. Yes, here is between 160 and 160, but don't leave out this line here. What line is this on either side? That's 140. So that whole green area is between 140 and 160. This area isn't a hill with a peak. What would you call this? That would be like a valley. So here, that's where you're going to show there's those two 160s. It does go down like a valley. These two spots did go up like the hills. One thing I can ever tell you is if you have two dots in a line, never, ever, ever just connect them with a straight line. There is never straight, flat hills or valleys. You just do have to take a minute to decide though, is it a hill or is it a valley? And you do that by looking to see, well, is it going to be higher or lower than the two numbers before it? So again, so this would have been the first one you did today during class. So this is C to D. Did yours look like that? And again, I think I checked on everybody. And the last one, G to H. This one threw some people off again. And I think if you, again, I'm going to stick with the same reminder that if you don't label them right off the bat and you had these blank, you probably would have gone 110, 120, 130, 140, 150, 160, 170, 180 and thought you were done. Saw a lot of people like that. But you have to label them. And the other important thing is to make sure you're getting all of those lines in there. A lot of people skipped either one of the 120s or one of the 110s. Again, it should look like this. We go down into a valley and then up into a hill. And how did I know that that was a valley? Because there's the 110. 110, here's the 100. This area in green is between 100 and 110. So that's why I dropped it down in between. And can I please emphasize, make it look like you're really going under on purpose. So I saw some people's lines. They just did that. And you might not even be able to, yeah, you guys can see it right there. Guys, don't make me guess if you really wanted it to go under, over, or straight across. What I mean is make it obvious like mine is here. I truly took this blue line under the 110, but higher than the 100. Don't make me guess what you had there. So how you feeling with profiles? Keeping in mind these last two were probably the hardest you would get. You hate them? Okay. I will remind you that that's why we practiced them now 2 days in a row and had them for homework. So the more practice you do, probably the less you hate them. So I don't know if you noticed on the board, but we're going to have a very quick 10-question quiz on Thursday. Yes, you have shortened periods on Thursday for our evacuation drill, but it is only 10 questions. It's on everything we've learned so far, which is doing the maps, making them, reading them, telling me which way the streams are flowing, which side of this hill is steep, looking at profiles, and then doing the last thing we're going to do today, which is gradient. So unless you do have a question, flip on over to page 34 where it says gradient. Yeah, Chris. So the evacuation drill would be like, for example, if that whole day that we had off and we had a bomb threat that day, if that happened while we were in school, they would want to get us out of the building into a safe spot. So we can't always go to the middle school because in that situation, the middle school was probably threatened as well. So they want to get us to a place that's safe, and they have us practice it just like fire drills so that you know what to do in that situation. So it's just a drill that we will be leaving this building. If you remember last year, we went to the middle school. Well, this year we're going to the church. I don't even know where we are. I think it's over there. It's on 16. So we're going to leave here, meet on the soccer field out front first, and then travel as a whole school over to that church. It won't be single file, but it will be the whole school moving at once. It is something that is going to hopefully look like organized chaos. So we're gonna be like blocking off that street. Yep, they're blocking it off. Cattaraugus County Sheriffs and the fire departments are blocking off Route 16. Yeah. So it was something that needs, so if you're traveling on Route 16 that day, so you're not because you're going to be in school, but there will be some traffic backup. Yeah. But if we're like evacuated right now, the cops aren't going to No, they are. Have you? Yep, they are. They would, that's why we do practice it. So our first thing is get out of the building and we meet at the soccer field out front. So then the cops have time. Think of how fast fire departments respond to things. The fire department, if there was a car accident on Route 16, they'd get there and block off traffic almost immediately. So it's the same deal. It will be almost immediately. And in case of real emergencies, I think teachers could even manage to block off. We're fully capable of standing in the middle of the road and telling cars to stop. People can tell in case of emergency, they do listen. You know that. All it takes is also one set of flashing lights. I think a mail truck could stop the traffic at that point if it was a real emergency. So, and they do it for car accidents all the time. Car accident happens, car stop.
Yeah, they do.
Yep. All right, let's do gradient though. Gradient. You probably have heard gradient in your real life before. Anybody have any ideas? Huh? Shading in science, not science. In art class, you'll use gradient. You'll kind of talk about the color wheel a little bit. Those are different shades of the same color. That's a gradient, absolutely. That's not quite what we're talking about here. How about in like construction or road work? Anybody know gradient? How about if I called it grade instead? Yeah, what's that mean, grading material? Okay. Gradient or grade is typically talking about the slope of the land. So when we just poured our patio this year, he made sure that our patio was sloped a little bit. Why would we want our patio sloped just a little bit? So the water ran off of it. So this is a real thing that you may someday actually want to think about when you own a home and you're doing work in the yard. So landscaping stuff needs to have a gradient. Driveways, roadways, they all have a nice slope to them. So gradient is really another way of thinking about slope. Or if we're talking about colors, it's also just how much it changes. So slope is really just a change in elevation, right? So gradient could be the change in the elevation of the land, or if we were talking about temperature gradient, it's talking about how much the temperature changes on the map. I know in math class, you guys have learned how to do slope of a graph. Now keep in mind, we're not using graphs. Yes, profiles kind of look like graphs, but they're not graphs in the way that you're used to looking at graphs. So we can't use that same formula, but luckily for you, there is formulas in science that you don't have to memorize. Where are they all? Yeah, everybody grab your reference table since you were supposed to do that anyway. And find the gradient formula, please. Found it. Everybody finds it, the air conditioner just kicked in and it's blowing down. So find the gradient formula right now, and we're going to write it in this upper corner right here. Gradient equals, don't say it out loud, find it and write it in that top corner. I'll give you guys a hint, or you will give your classmates a hint. What page are you on? 1. That's the front cover. No, the front cover. All right, what is it? Change in field value divided by distance. So right off the bat, we've got some weird words. Change in field value. Do you guys remember a couple weeks ago when I told you what a field was? Because it's not just that out there. It's not just that out that window. It's not just that thing over on the turf. What did I say a field was? No, it's not just a wide open space. Guys, remember what we said a field was? Well, if you don't, it's on the first page of your notes. Go back and read it. Okay, that was not a request, that was a demand. So on the first page of notes we took this week, this chapter, might even be the very first word we wrote.
Generic term being used for anything being measured.
It's a generic term for anything that's being measured. So it could be this field and I could go out and measure the elevation of that field. It could be that corn crop over there and I could go out and measure that. It's whatever's being measured. So on all these maps we've been doing, what have we been measuring? We've been measuring elevation. So in this case, it's going to be the change in elevation divided by distance. If it was one of the maps that Sam brought in for me for his cornfield, it would be the change in production divided by distance. If it was that aches and pains one, it would be the change in aches and pains divided by distance. So it's a change in whatever's being measured divided by distance. So to do this, you'll see I gave you 5 boxes just like yesterday. If you follow these 5 steps, you'll be able to calculate gradient beautifully. Sorry, just combined 2 words there. So if you follow these 5 steps, you'll have no problem calculating gradient. Are you ready for them? Never mind, it's not a question. You are ready for them. No, it wasn't a question. No, it wasn't a question. All of you who seem to think it was a question, it's not. Ready? Step 1. This might even sound familiar. Determine the contour interval and write it in for each line. Yeah, it should sound familiar. It was step 1 yesterday. The good news is if they're going to have you draw a profile, probably the next question is going to be calculate the gradient. So you will have already done step 1 once. You only have to do it once. Determine the contour interval and write it in for each line. So in this case, I have 20 labeled, skipped a line, 60 labeled. What's missing? 40. By the way, is 40 the contour interval? No, 20 is. What the lines are going up by is the interval. All right, that's step 1. Ready for step 2? Step 2 is to calculate the change. I want to reword this. Calculate the change in field value. Calculate the change in field value between the points that will be used to determine gradient. Guys, be careful. And make sure you always do between the 2 letters they tell you. So they might be making you draw a profile between A and B, and then calculate the gradient between C and D. Why? Because they're jerk faces, but they do that on purpose. Because again, they like to test how much you're paying attention. Read all the words and do what they say. So make sure you figure out what letters they want you to do it between. For this one, I'm going to calculate the gradient between A and B. How will I figure out how much it changes? What math will I do to figure out the change? Subtraction, yeah. So if I see that A is 20 and B is 60, how will I figure out the change? I subtract. 60 minus 20 would give me 40. All right, step 3, measure the distance between the 2 points. You will use the map scale, not a ruler. Step 3. So you can use the same scrap paper we were using last period. Or yesterday, today, whatever. Do you write rule 3, step 3? So remember, I talked about this at the beginning of the school year. You are going to bring your scrap paper to the map. You're not going to try and use your pencil. You're not going to try and use your finger to measure how far apart they are. You're going to actually mark it on your scrap paper. Step 4, you're going to write the formula in for gradient. And you may notice that that's really taking the change in field value. That's what we did in step 2. And dividing it by distance. That's what we did in step 3. So you're just plugging them in. I also remind you, no naked numbers. So you would want these labeled. The change in field value would be in feet or meters. The change in the distance would be in kilometers or miles. And then finally, what do you think step 5 is? Right, yeah, solve. So step 5 is to calculate it or solve. So we have time to do one practice, and then you'll notice you have homework. It sounds like a lot of homework, pages 36 through 39, but it's only 3 problems. It might be 4 problems, 36, 37, 38, 39, 4 math problems. So we're gonna go ahead and do an example on page 35 right now. So page 35. So stop sharing. All right, page 35 looks like this. We got another map. Step 1, determine the contour interval and write it in for each line. Well, again, I've got 10 and 20 labeled with 1 line in between them. So what am I missing? 15. Is there anything to write then for step 1? Nope. Step 1 is labeled on the map. Step 2, determine the change in field value or calculate the change in field value. So I'm going to kind of write this out more detailed than you have to, but I think it's good to have a good example. What is the elevation at A? 10. What is the elevation at B? 20. So how do I figure out the change? Subtract 20 minus 10 equals 10. By the way, we forgot to read the direction. It does say elevation are in feet. So no naked numbers labeled at 10 feet. Step 3, figure out how far apart they are. How will I do that? So determine the distance. No, this is where we use our scrap paper. So you are going to go to the line. We don't care about all the lines. We only care about B and A. So this isn't like a profile where you got to mark all the lines. I only care about B and A. Now I bring this to the map scale, put B at 0. Oh shoot, my map scale is too short. What do? You could extend it, or here's a simple trick. If I mark this off as 6, because that's what it tells me, that's 6 miles. Now if I drag that 6 over to the 0, so instead of it being 0 there, now that line's 6. What is this next line? That's 7. Am I all the way over to 8? No. What would you call that? 7.5? Maybe 7.6. Mine looks like it's a little farther over. That's 7.6, and this is listed in miles. MI. Step 5, write the formula in. You can change it. You can shorten it up. Change divided by distance. And again, remember, that's step 2 divided by step 3. So I just take my step 2 answer, 10 feet, divide it by my step 3 answer, 7.6 miles. Plug that into your calculator. Shoot. 10 divided by 7.6 is 1.3, and then the units are listed right there. Feet over miles. I would like you guys to do page 36, 37, 38 for homework, and 39. I will also show you, if you haven't packed up yet, the dot for B is right below the letter B on the next one. 36 through 39 is homework. You too. Sorry to rush there, guys.